Okay, so we've been doing derivation with functions with logarithms in them for a couple of days now. And the thing you have to remember is where that came from. The original rule that I gave you wasn't a rule for derivation, it was for integration. And that was the integral of du over u equals the natural log of the absolute value of u plus c. And if it's a definite integral, then you have to put in, do what you do for definite integrals. You'll have an a and a b here, and you'll have to put them in and find the difference. This is where it came from, and all I'm going to do right now is do some examples of how this applies. Simplest example is if you just have 1 over x. Just get used to all the different notations. You might see the integral looking like this, and that would be the natural log of the absolute value of x plus c. Don't forget the plus c. So, for some examples of this, I'm going to have some examples ready because I don't like to make these up. But any quick questions on this idea on the board? You do need the absolute value.
Isn't this what we've been doing in class pretty much? Except absolute valuing and stuff?
Well, we were doing it the other way. We were looking at functions with this and deriving it. Yeah.
But it's the same.
The same thing, but let me show you how this one gets a little bit crazy and some examples of it. And this is going to play into u substitution again, which not everyone likes. So you have to remember every other derivative and antiderivative because you've got to spot them.
They're not using this?
We're using them, but I'm going to, I don't have as much board space.
Are we supposed to write those down?
See how well you know them. Okay, take a look at this antiderivative. The goal now, like with u substitution, the goal is to find the u and the du and make sure that you have both. But now, unlike the other u substitution we did, the u is going to be on the bottom. Okay, so what do you think u should be in this one? For my u substitution. In the original formula,
oh, it was the
du was on the bottom, right?
Okay.
So what's on the bottom here?
Wait, in the original formula, u.
Yeah. So what do you think u has to be here?
That one. That bottom piece.
Okay. So u has to be 2x plus 5. All right. What's the derivative of 2x plus 5?
2.
Except with this, we're doing implicit differentiation.
Oh, okay. Yeah.
So it would be 2 dx.
All right.
All right. So, Remy, do I have a 2 dx here?
What? No.
Yes. Stop. Slow down. Slow down.
No.
I do not have a 2 dx here. I have a 2 down here, but that doesn't help me. So for this to line up as a du over u, I know we haven't done u substitution in a while, but focus guys. I need to put a 2 in there. And am I allowed to just put a 2 in there?
No.
Well, what else do I have to do?
You have to multiply it. So about multiply by the 1/2.
Yep, I have to put the reciprocal on the outside. Okay? All right. So I can put the 2 in here, and then what I'm going to get is 1/2 natural log of du over u, which is, I'm sorry, 1/2 the integral of du over u, which is 1/2 the natural log of the absolute value of 2x plus 5 plus c. So I'm putting the 2x plus 5 back into the u. Any questions on this one?
No. Is that all?
That's all it is. You have to make sure the u and the du match. Don't worry, they'll get worse. Okay? But you have got to remember everything we've ever done.
Well, we were doing this stuff at the beginning of the year, but not with logarithms.
No, not with logarithms. So yeah, we were doing the u substitution earlier. All right? Any questions on this example before we go on to another one? Okay. Let's start making it a little bit more interesting. A lot of times, you'll be given an algebraic expression that looks confusing, and then you have to mix and match. Okay, so, or possibly do some factoring. Let's take a look at this one here. And I want to make sure I give you one that works well. Okay, I like this one. Here's your next example. And this is, I want to make sure I don't copy these wrong. X squared minus 2x over x cubed minus 3x squared dx. Okay. Nate, if it's a natural log situation, where are we going to find our u? On the top or the bottom? Bottom part. So u pretty much has to be something down here, x cubed minus 3x squared. All right. Danny, what do you think that's going to make du?
Well, since it's going to be implicit thingy, it's going to be 3x squared dx
Good.
minus 6x dx.
Minus 6x dx. If I want to, can I factor the dx out of there?
I guess so, yeah.
Yeah. Okay, that'll work. Good. Good memory on the implicit as well. All right. I've got a dx, that's not a problem. Always doing an integral. Do I have 3x squared minus 6x on top, though?
What? Oh, no, you don't.
No, I don't. So is there anything I do? Do I write can't be done?
By 3, and then 0 separables on the outside.
Very good. I'll show this extra step. This one, I didn't leave enough room up there. So if I take the numerator, what did you say to multiply it by, Danny?
3.
Excellent. So Danny noticed that you can multiply the numerator by 3, bring a 1/3 out here, and we'll get 3x squared minus 6x, which is what we have to have. You have to have the derivative of what's on the bottom in order to proceed. Remember with u substitution, you always need a u and a du, and if you think it's going to be a natural logarithm situation, you have to have the u on the bottom and the du on the top. So this becomes 1/3 times the integral of 3x squared minus 6x over x cubed minus 3x squared dx. I now do have u over du over u, excuse me. So this is 1/3 the natural logarithm of the absolute value of, sorry to write the wrong one, be careful with that, it's easy to do. X cubed minus 3x squared. Never forget the plus c unless it's a definite integral. Any questions on that one?
I'm just trying to get down.
Okay. Take a look at it. Danny, that was a good eye spotting that we had something very similar to 3x squared minus 6x. We just had to multiply by the 3.
Mm-hmm.
Now,
I'm going to start erasing the top part.
okay,
I just need to write the last, literally the last equation.
gotcha. All right, here's my next example. That's all we're going to do today, some examples of this, get you to the rhythm of them. Okay, what is u going to be in this case? In this integral, what do you think u is going to be?
U is going to be x. Oh, wait, sorry, we're at the top. U is going to be 9 minus x squared.
That would work. U will be 9 minus x squared. Someone other than Danny now, what's du going to be?
This 1/2. Wait.
You're skipping ahead to something else, I think. Just look at the u.
Oh, 2x. Negative 2x.
Negative 2x. Negative 2x. What are you forgetting, Ronnie?
Plus 2.
No, that's when you integrate. Slow down, buddy. Negative 2x is like implicit
Oh,
differentiation.
dx. Oh, wow.
dx. There you go. There you go. All right, so you got the du there. Do we have negative 2x on the top?
No.
No, but we can insert it. I can put a negative 2 there and a negative 1/2 out here. So what this gets me then is negative 1/2 the integral of du over square root of u. Is this where I jump to the natural logarithm?
Yes.
Seems obvious, isn't it? This is a trap. You fell for it, Remy. The natural logarithm is only the case where you have 1 over u. Another way to write this over here is I can write this as u to the negative 1 du. That's another way to write du over u. A u in the denominator is u to the negative 1. Do I have u to the negative 1 here?
No.
What do I have? What
U to
exponent?
the negative, no, wait, u to the negative 1/2.
Yes, if I bring the u out of the denominator, it'd have to be negative 1/2. Good job, you're redeeming yourself. So that's u to the negative 1/2.
I think I just missed something. What?
Okay, this looks like a natural logarithm problem, and your book throws a couple of these in there because you have a u on the bottom and a du on the top. But the natural logarithm antiderivative, this case, is very, very specific. It only works for du over u. In other words, u to the negative 1. But this book and my tests and the AP exam are going to mix and match. You do have a u on the bottom and its derivative on the top, but this u is in a square root. So what we're actually looking at here is u to the negative 1/2, which is not the same as u to the negative 1. So this is not a natural logarithm situation.
So that is wrong.
Well, this is correct, but if we go from here to the natural log of u, we'll be wrong. This one you just treat like the powers rule.
I'm sorry, how did you jump there though?
From here to here?
No, yeah, so you're just writing them in du and
Yes.
du, okay.
Yeah,
Then
from
you
over
put it
here.
out, then you make it like that.
Yep. And now, so this situation looks like a natural logarithm case, but it's not. This is just the powers rule. So this becomes negative 1/2 integral. And then what do we do when we're anti-deriving? I'll take you through this first one because we've been deriving a lot lately. You add 1 to the exponent. I don't write the integral sign anymore. Well, it's really annoying. What happens when you add 1 to negative 1/2? What do you get? Negative 1/2 plus 1.
It's positive 1/2.
Positive 1/2, good. And then you bring down the reciprocal of your new exponent. So now we've anti-derived. No logarithms here. If you don't see du over u exactly, which is the same thing as u raised to the negative 1 power, if you don't see that, you don't do a natural logarithm, you go back to some other thing we learned. It's also another case we're going to learn that looks very similar to this. Negative 1/2 times 2 over 1 is just negative 1. Let's go back to what u was. U was 9 minus x squared. That's to the 1/2 power plus c. So your final answer is negative square root 9 minus x squared plus c.
And stuff in red is,
Just for the rule.
alright.
That's just the rule we're going to follow the whole day if we have this exact situation. Here's where the judgment's going to come in. You got to know what you're looking at.
Right.
You could see du over u, but if you miss that it's in a radical, you'll give a logarithm answer,
Right.
and that won't be correct. I don't think there's no trig tonight, but I might preview a trig example.
Is that what we did one day?
Yeah, where'd my planner go?
Yeah, a little bit. Well, maybe you'll see. All right, here's what I want to try.
Wait, can you not erase the very bottom? Yeah.
Not yet. Okay. Here's one.
Ooh,
This is going to strain your memory from algebra 2. Okay, you guys ready for that?
yeah.
So this is going to be the integral of 2x squared plus 7x minus 3 over x minus 2 dx. Okay, take a look at this. The goal, remember, is to have a derivative over something, over what you took the derivative of. Derivative of something over something. Is there any way you can derive x minus 2 and get this polynomial on the top?
No.
No, derive x
Not
minus
without
2.
some serious thing.
something, no, it's just, you derive x minus 2, you get 1.
So is the u on top this time? Is it reverse, like a negative?
Yeah, that'd be an interesting idea, but no, there's no case, we're not going to look at any cases where the derivative's in the denominator. That's just not going to happen this year.
Alright.
So, put that out of your mind.
Is that like a high-level calculus thing?
It's not really a thing at all, actually, but
I mean,
differentials
they
are really
could
weird.
put -1.
Yeah,
I mean, this doesn't happen.
yeah. I never even encountered that in college, is all I'll tell you right now. So this can't be done in its current form. There's a couple things we can do. We get a little lucky with this one. I'll give you a hint. We got lucky because this is a first degree binomial on the bottom. Because here's the only thing I can think of to do from here, and that is to work out the polynomial long division.
Oh.
Now, polynomial long, I'll give you guys a choice. We have a choice for one reason. When it's just x plus or minus a number, you can do synthetic division instead. But if this were x squared, we would have to do long division.
Could you somehow, like, FOIL the one on top?
Reverse FOIL it and see if we have a
Reverse FOIL,
factor? Yeah,
I
sometimes
think you
that'll
might have
work.
a factor, but I'm not sure.
You know, honestly, if you're good with the synthetic long division, it's the fastest way to check.
Alright, that's fine.
Because if we don't get a remainder, then we know it was an even factor.
Right.
But yeah, you should check that. I'm pretty sure this one doesn't. But let's see what we get here. So for synthetic long division, you switch the sign, you bring down the coefficients, you bring down the 2. 2 times 2 is 4. 11. I don't think I'm going to get a 0, Danny.
Okay, well, then you get really, one of them is like x plus 2 or something.
Yeah. So what is this? Do you guys remember what this means?
It means it does not have an x intercept.
That's very good. Now you're going back to Descartes' rule of signs and all the graphing we did. It means this is definitely not an x-intercept. It also means we have a remainder. Okay, so what this answer means is we can rewrite this integral. Okay? With synthetic division, we started with an x squared, so that's going to be a 2x. This is going to be plus 11, and then you put the remainder on top of what you were dividing by. So what we've done is we've split our original integral up here from trinomial over binomial into 3 terms.
Who came up with this stuff?
Now, this looks annoying. We haven't done anything that looked exactly like this, right?
No, I don't think
Okay.
so.
Now,
Actually, I kind of remember putting the remainder on top of that thingy, but that might have been from another thing.
well, I hope you remember. You should remember that from pre-calculus and algebra 2. But in terms of integrals, we haven't done one that looks like this.
No.
So I'm going to do a little trick here. I'm going to split this up. I'm going to split this up into the integral of 2x dx. We've done things like that, right? Okay. Plus
Oh, because you're like expanding them.
distributing. I
Or
like to say.
distributing. Well,
Plus,
you'll be expanding them and then the x minus 2, right?
hold that thought. Plus 11 dx. We've done things like that, right? And plus the integral of 19 over x minus 2. And we just did things like that just now. So let's start simple. What's the integral of 2x dx? What derives to 2x?
X squared.
Nate, do you agree? You looked doubtful.
Isn't it 1/2 x squared?
Not yes, but only with the 2 there, it cancels out the 1/2.
Oh, right.
Good question though. Okay. Antiderive 11 dx.
You get. Oh, wow.
It's easier than you're thinking. What has 11 as its derivative?
Oh, 11x.
Well.
11x. Good memory.
Yeah.
We haven't done these simple antiderivatives in a while. All right, now I'm going to rewrite this last one a little bit differently.
I'm
I'm
thinking too much.
going to pull the 19 out. Now I'm going to write this as dx over x minus 2. I haven't been writing the plus c's as I go along, so I'm just going to put 1 plus c at the end when I'm done. This is what we've been doing today. The derivative of x minus 2 is just dx. I have du over u right here. So this one, this is the new thing, plus 19 natural log absolute value x minus 2. Now I put the plus c. This is a big plus c that works for all three of these antiderivatives.
We're going to do c divided by 3.
Doesn't really matter because I mean c is some
Yeah, it's just a number.
it's some number, so you add three some numbers together, you get some new number.
You want me to put that wrong?
Let's not put misinformation on the internet, please. There's enough of that there.
That's what it's for.
You're right. Any questions on this one? You get the idea? If you see something like this, higher degree polynomial over lower degree, do the synthetic division, do the polynomial division, look for common factors. Maybe you can cross out a common factor, that'll work sometimes. But do some kind of division. Usually when you get to these problems, they intentionally give you ones with a remainder, so that you'll have to do the logarithm part, at least in the logarithm section of the book. You'll have to antiderive to the natural log on just one of the terms. Does that strategy make some sense?
Yeah.
Okay. You sound so confident there, but I'll take it. How do these get a little bit? Okay, I'm going to move on to some examples of some things that won't be in the homework tonight, but we'll talk about a little bit next week. This should give you starting hints. Yeah. The answers are in the back of the homework I'm giving you tonight. Nothing wrong with working backwards from them for now. If that'll help you, but let's look at one we haven't done yet. Here we go.
Wait, you give us 23 problems to do.
Yeah, first ones are easy.
I mean, probably like anti-derived 1.
No, it's like antiderivative 1 over x, or 5 over x, I think is the first one. So, hope we can handle that one. What could this possibly have to do with natural logarithms?
Because anti-deriving stuff, or those things get you stuff.
Okay, that's a very general answer, but anything more specific? When we were doing trig identities with this, and I said if you had no other clue, what was one thing to always try to do? Something you can do to all the tangents and cotangents and secants.
Oh, make them fractions.
Make them fractions with
Make
what?
them, this, in this one's case,
Cosine x over
cosine,
sine x.
Good.
Or-
Good.
cosecant over secant.
Okay. Yeah, we could do that. That's kind of crazy. I'm going to stick with this one, though, and hopefully you'll see why in a second. Okay, so the antiderivative of cotangent can be written as the antiderivative of cosine over sine. With cosine over sine, all right, remember, we're looking for a u and a du. You see a u and a du,
Yeah.
something that's derivative there? What's the u, Remy?
Sine x.
Awesome. What's the du? Cosine x. Okay, so now I can rewrite this as the integral, boom, du over u, which is the natural log of the absolute value of whatever was on the bottom, sine x plus c. So cotangent antiderives the natural log of sine x. What do you think tangent antiderives to? Right over here.
The natural log of cosine.
Let's work it out to be sure.
Secant. Or no, cosecant. I can't even think.
You're making logical guesses, but let's work it out a bit. Here's tangent x, okay? So I'm going to change this to sine over cosine, right? Do I have du over u now?
Yes.
Oh, so close.
Oh.
If
no.
u is cosine x, it's one other than Dan.
Oh.
What's the derivative of cosine? Remember that?
Negative sine x.
Yeah.
Negative sine x. Okay, good. Negative sine x dx, which I didn't quite leave enough room for there. Okay, so am I doomed then? Am I
Wait,
trapped?
wouldn't du be cosine x dx on the other side or no?
Thank you, Remy. I picked on you for that a minute ago, so I deserve that. Yes, it should be. Gotta keep track of your implicit differentiation in this case. All right, so I need a negative sine x on top. Am I just doomed? Can I not do it? What can I do?
You need a negative sine x.
Yeah.
I'll multiply by negative 1 over negative.
That's a good way to picture what you're saying. Multiply by like -1 over negative, multiply it by I just like to think of it as,
Just multiply it all by negative. Multiply it in the in and out by
let's
negative.
just put two negatives in, because they'll cancel out and make a positive,
I'll
right?
just stop that.
Sorry. So now we have, this is going to be negative natural log of the absolute value of cosine x plus c. Now, Danny, you said something interesting a minute ago. You said it might be secant.
Yeah.
Take a look at this trick. Are you ready?
Yeah.
I can take an exponent and I can whoosh it up inside the logarithm, right? A coefficient, excuse me. You can take a coefficient, I can bring it up inside the logarithm as an exponent, right? We were doing that trick
Yeah.
yesterday. All right. Raised to the negative 1 power means reciprocal. What is the reciprocal of cosine?
Reciprocal cosine is
Secant. So either you were thinking 10 steps ahead, or that was a very lucky guess.
I'm not sure actually.
Most books will show it as a natural log, as negative natural log cosine, and you want to be careful with the absolute value on things like that. But yeah, that should work though. Any question on these ideas? You get two more trigonometric antiderivatives now. Any question on those ideas?
Right. I don't think so.
All right. They're not in the
Homework.
they're not in the homework tonight. I'll give you one more. Fairly, I'll give you one more that I hope is. No, I don't like that one. That's the one I want. Okay. I'll give you one more designed to trick you. You guys ready to be tricked?
Sure. Watch this not be tricked.
Hoping not. Okay. What's up with this one?
Ooh. That one, it looks like you're setting it as du over u.
But can I derive x and ever get natural log of x?
No.
Yeah, so I can't have du over u here.
So is the u, I mean, is the du actually like 1?
Well, let's see. What else
And
can
it's
you?
multiplied by ln x?
Really, we've got two choices for u and du, right?
Alright.
What are our two choices for u?
X and ln x?
X and ln x.
Yeah.
If I
ln
make
x
it,
is probably it.
yeah, if I make it this, if I make u equal to x, du is just going to be 1. I've got to deal with this natural log of x. I can't ignore it. I'm going to make u the natural log of x. What's du going to be?
X. Or x negative.
X to the negative 1, okay? Let's say 1 over x dx. Now, can I rewrite this as the integral of natural log of x times 1 over x dx? Am I allowed to do that?
Yeah.
Yeah.
Let me see what you put it.
Boom. I've got my u and I've got my du. The antiderivative of u du is just 1/2 u squared plus c. So this is going to be 1/2 natural log of x squared plus c. I have to use parentheses here. This is not natural log of x squared where I can whoosh down the exponent. This is natural log of x whole thing squared. I can't use any of the properties of logarithms to simplify. That's my final answer. So for this one, we didn't have to use du over u in the actual integral. Throughout the year, I'm going to throw some of these on tests where I'll put like, you know, ones that look like you have to do one thing, but really you have to do another. There's a lot of antiderivatives that look alike. And there's one subtle difference, an exponent somewhere, and you suddenly can't do it the way you thought. Any questions on this?
Come to this straight now. I don't think I have any.
All right, I've given
This
you a
is
lot
not on
of...
the homework.
This part isn't now. There might be one like this, I'm not sure. There's not any to trig, definitely. And yeah, the big thing is the biggest thing on this is how many algebra tricks you remember. If you've completely forgotten how all your algebra works, this will be more difficult than if you haven't. because sometimes there's like the polynomial long division, that will come up a few times, and also rewriting the exponents could be helpful. All right, this should be enough to get you guys through, get you guys started at least, and we'll stop there.
Next time we can.
Oh, man.